So we talked about the general strategy for factoring, and now I'm just going to show you a few examples. In the next couple of videos, you'll see about 6 examples. These cannot cover all the possible different ways that factoring problems can look, but it'll give you a sense of how to work through the general strategy. So in this first one, immediately I want to pull away some GCFs, and I see that there's a common factor of 7 in the numbers, and it looks like there's a common factor of x. So I'm going to pull off a 7x and see what I get left with. Well, x squared on the first term, I like that already, minus 3x in the second, and then minus 10. Perfect. I like the looks of that. That's a simple trinomial left over in the brackets. So let me go ahead and factor that. So for a simple trinomial, I'm looking for two things that multiply to negative 10 and add to negative 3. And I could go with negative 5 and positive 2. So for a simple trinomial, 7x, what I do is I just take those two numbers I found here and I throw them into my factored form of the trinomial. So I'm done. Next up, well, those don't look like perfect squares, so it doesn't look like a difference of squares yet, but maybe if I factor off a greatest common factor. So what can each of these guys be divided by? And I pull out my calculator and I try some different numbers, and they can each be divided by 6. So why don't I start there? If there's more I can pull off after, I'll do that. But to start with, I'll factor off a 6, and I'm left with 4y squared minus, and 150 divided by 6 with my calculator, I get 25. Ah, perfect. That's a difference of squares. There's my a is 2y, and my b would be 5. So 4y squared minus 25 is going to factor into 2y plus 5 times 2y minus 5, using that pattern of the difference of squares. Next example, I take a careful look and I don't see any greatest common factor I can take away. So now I'm thinking about do I want to factor this as a messy trinomial, or maybe this is a perfect square trinomial? Because if it is, that makes my life a lot easier. So looking at this, that 4a squared could be 2a, and that 9b squared could be 3b squared, all squared. And if this middle term is plus or minus 2ab, then it's a perfect square trinomial, and I can factor this pretty quickly. So let's start with 2 times a is 2a, and times b is 3b. Multiply those together, I get 12ab. Well, great, that works. So this is a perfect square trinomial, which means I can just go right ahead and factor it as 2a, and I'm going to use minus b squared, and I'm using that minus because the middle term in the original trinomial is negative.